Okay, once again, we're taking a look at the third and final example via graph. Our first example, we had two lines with two different slopes eventually meet at a single point. Again, that was referred to as consistent independent. Then if we had two lines that had the same slope but different y-intercepts, they ran parallel to each other and they never touch. Okay, they don't have a single point in common. That's referred to as no solution. Okay, another term we'll use is inconsistent. Now, the last case we're going to encounter over here. This is the third possible scenario we could run into, either one solution, no solution, or this final example. So I have my first equation is 2x plus 3y equals 6. And my second is 4x plus 6y is equal to 12. Okay, again, I would prefer, if I'm written in this standard form, elimination method works the best, which we'll be learning at the end of the week. But for the graphical purposes, so we can visually see what we're trying to do, we're going to try and move it into slope-intercept and take a look at it on the graph. So I'm going to start with number 1. The first thing I would do is subtract the 2x from both sides. That gives me 3y equals negative 2x plus 6. Then I would divide everything by 3. And I'd end up with the equation y equals negative 2/3 x plus 2. Okay, from that point, I'll go up 2 on the y-axis, and we'll go down 2 over 3, and we'll draw our line as best we can. That's the infinite number of solutions to that equation there. Now, let's do the same thing and get equation number 2, 4x plus 6y equals 12. Let's get that into slope-intercept form and make it a little bit easier to graph. So the first thing we would do is subtract 4x from both sides. So 6y equals negative 4x plus 12. Then we're going to divide each term by 6. And that's going to reduce to y equals negative 2/3 x again plus 2. So you see we started off with two different equations, but when we simplified it, it was in fact the same exact graph. So what we're going to have here is this line is going to be graphed on top of a line that's already there. So I would go to 2 on the y-axis, down 2 over 3, and I would try to sketch that line directly on top of the other line. Okay? So when you have a line that represents an infinite number of solutions to one equation, and you graph a line on top of that, you're going to have infinitely many solutions in common. Infinitely many solutions in common. Okay, now since there are solutions in common, we call it consistent. But since all of the points are in common, we say consistent dependent. So one point in common, it's consistent independent. An infinite number of points in common, it's consistent dependent.